Dear friends, we are here with the next unsolved problem of gear, problem number 6. The data of the problem is like this. Two gears in mesh have a module of 10 mm and a pressure angle of 25 degree. The pinion has 20 teeth and the gear has 52. The addendum on both the gears is equal to 1 module. Here, determine the 1. Number of pairs of teeth in contact. 2. Angle of action of the pinion and wheel. 3rd, ratio of the sliding velocity to the rolling velocity at the pitch point, at the beginning and end of engagement. Friends, let us note down the given data first. Here it has been given then module, that is M is equal to 10 millimeter. Then pressure angle is given, that is phi is equal to 25 degree. The number of teeth on pinion is given. Let us denote it by small t is equal to 20 and number of teeth on the gear capital T is equal to 52. Addendum on both gears is equal to 1 module. That module is given 10 mm. So addendum is equal to 10 millimeter. We have to find out number of pairs of teeth in contact. That we can say we need to find out contact ratio, that is number of pairs of teeth in contact. That is nothing but is equal to contact ratio. Now angle of action of the pinion and wheel, we denote it is delta P is to be find out and delta G is to be find out, and velocity ratio to the sliding ratio. Ratio of sliding velocity to the rolling velocity, that is sliding velocity upon rolling velocity at P, sliding velocity upon rolling velocity at start of engagement, and sliding velocity upon rolling velocity at the end of engagement. This is to be find out. Here we need to find out contact ratio. So writing contact ratio is equal to arc of contact divided by circular pitch. Here, so we need to find out arc of contact. So arc of contact is equal to path of contact divided by cos phi, and path of contact here again we need to calculate, that is given by path of contact is equal to path of approach plus path of recess. And these two are given by respectively is equal to under root of RA square, that is a addendum radius of gear, minus R square, that is the pitch radius of gear, into cos square phi minus R sin phi. This gives path of approach plus path of recess given by, that is RA square, that is a RA is addendum radius of pinion, minus R square, that is pitch radius of pinion, into cos phi minus R sin phi. Here we need to calculate the pitch radius and addendum radius. So it has been given in the data that for gear, module is equal to pitch circle diameter by number of teeth. That gives 10 is equal to D upon 52. Capital T, number of teeth of the gear are given 52, and that implies we found D is equal to 520 millimeter, and hence the radius, pitch radius R is equal to half of this, that is 260 millimeter. So the addendum radius is given RA is equal to R plus addendum, and that is equal to 10 mm. So that is equal to 260 plus 10 is equal to 270 millimeter. And for pinion, M is equal to D by T, that gives 10 is equal to D by number of teeth on the pinion are 20. So we find pitch diameter of the pinion is equal to 200 mm. Hence the pitch radius of pinion is equal to 100 millimeter. So the addendum radius of pinion is equal to pitch radius plus addendum is equal to, that is 100 plus 10 is equal to 110 millimeter. So substituting these values of addendum radius and pitch radius of gear and addendum radius and pitch radius of pinion in this equation of path of contact, we will find that is path of contact is equal to, in bracket, under root of 270 square minus 260 square into cos square 25 degree minus 260 into sin 25 degree plus under root of 110 square minus 100 square into cos square 25 degree minus 100 into sine 25 degree. Upon calculation, we found individually 2r, that is path of approach is 21.92 millimeter and path of recess, this part we found is equal to 20.08. So total path of contact is equal to 42.0 millimeter. Now we can calculate arc of contact from this, that is arc of contact is given by path of contact divided by cos phi, and that gives 42.0 divided by cos of 25 degree, and that on calculation we found is 46.35 millimeter. Now from this we can calculate contact ratio. So contact ratio is equal to arc of contact divided by circular pitch, and that is equal to 46.35 divided by circular pitch, that is equal to pi into module, and that is equal to 46.35 divided by pi into 10. On calculation we found is equal to 1.475. This is our first answer of the problem asked, that is contact ratio. Now angle of action of gear. Let us calculate angle of action of gear, that is equal to delta G is given by arc of contact divided by pitch radius of gear, and that is equal to 46.35 divided by pitch radius of gear is 260 mm. On calculation we found is equal to 0.178269 radian. Converting into degree, we found it is equal to 10.21 degree. Now similarly, angle of action of pinion, we can calculate angle of action of pinion is equal to delta P, that is equal to arc of contact divided by pitch radius of pinion. And that is equal to 46.35 divided by pitch radius of pinion is 100. On calculation we found is equal to 0.4635 radian, converting into degree, it is equal to 26.55 degree. This becomes the second answer of our problem. Now, let us find out the sliding velocity ratio. So, we know that sliding velocity is given by sliding velocity is equal to, that is, angular velocity of pinion plus angular velocity of gear into distance between point of contact and pitch point. Let us denote it is by xy. Same. So, and rolling velocity is given by RV is equal to pitch line velocity and that is equal to angular speed of pinion into pitch radius of pinion. Now, we have to find out the ratio of these two at three locations. So, first at pitch point. Now, at pitch point, the distance between point of contact and pitch point xy will be 0. So, the ratio of these two velocity, that is sliding velocity upon rolling velocity at pitch point, will be equal to omega p plus omega g into 0 divided by omega p into r, and that is equal to 0. Now, at start of engagement, the distance between point of contact and pitch point, that is xy, will be equal to path of approach. And that is given is equal to, we have calculated 21.92 millimeter. So, we can write that sliding velocity upon rolling velocity at the start of engagement is E is equal to omega p plus omega g into 21.92 divided by omega p into r. Now, it has been given that omega p upon omega g, that is velocity ratio of pinion to gear, is given by the ratio of number teeth in reciprocal, capital T upon small t, and that is known to us is equal to capital 2 is 52 and small t is equal to 20. So, we can write from this that omega g, angular velocity of gear, is equal to 20 upon 52 into angular velocity of pinion. Now, substituting this relation in above equation, so we found that velocity ratio of sliding velocity and rolling velocity at start of engagement is equal to substituting omega p, value of omega p in terms of omega g is equal to omega p plus 20 upon 52 into omega p multiplied by 21.92 divided by omega p into r, that is given is equal to 100 milliliter. So on simplifying this, we found it is equal to 72 divided by 52 into 21.92 upon 100. On calculation, we found is equal to 0.303, and at the end of engagement, now at the end of engagement, xy, the distance between point of contact and pitch point will be equal to the path of recess. So the velocity ratio, that is sliding velocity to rolling velocity at the end of engagement, is equal to omega p plus omega g into that path of recess that we have calculated is equal to 20.08 divided by omega p into 100. So substituting the values of omega g in terms of omega p, we can write is equal to omega p plus 20 upon 52 into omega p multiplied by 20.08 divided by omega p into 100, and that gives us 72 by 52 into 20.08 divided by 100. Upon calculation, we found that sliding velocity upon rolling velocity at end of engagement is equal to 0.278. So these are our answers of the problem. Thank you.